can. So without further hesitation, let's all learn about Yellowstone's newest thermal area from research scientist Greg Vaughan.
Hi everyone, and thanks for watching. My name is Greg Vaughan. I'm a research scientist at the USGS Astrogeology Science Center here in Flagstaff, Arizona, and I also work for the Yellowstone Volcano Observatory. And I'm really excited to share with you some work that I've been doing in Yellowstone for the last couple of years that is associated with a new thermal area that has recently appeared. The work that I'm going to be talking about is focused on one area that's in this photograph right here. It's focused on this area right here. And one of the interesting things about this area right here is that 20 years ago, it looked like this. Okay, it was healthy, thick forest full of lodgepole pine trees. And I could ask you, what do you think this is? But I'm afraid the title of my talk sort of gives that away. But there are other really interesting questions we can ask about it, like when did this first appear? How long has it been sneaking up on us? And how did I find it? And how long, how did I miss it before? And another really important question is, what could have caused this to appear, and what does it all mean with respect to the Yellowstone thermal system? So the first thing I want to do is step back a little bit, and we'll take a look at Yellowstone Park as a whole. First of all, if you've never been there, it's a beautiful place. You should go to Yellowstone if you ever get a chance to. It's an amazing place. It's in the northwest corner of Wyoming. And this map on the left is a map of Yellowstone Park, the whole park. It's a very big place. It's about 90 kilometers from east to west and about 100 kilometers north to south tall. So if you ever do get a chance to go there, plan to spend some time, because it's a really big park and there's a lot of things to see inside the park. Now this map shows a whole lot of things. One of the things it shows is topography in the park. The gray scale color in the background shows where the hills and the valleys are, and the mountains in the park. And the other thing it shows is some of the lakes. Some of the larger lakes in the park are shown in blue on this map. And I'm also showing some of the geologic features in the park. This dark black line here is the rim of the Yellowstone caldera, which is the caldera that collapsed after the last really big super eruption, which happened about 631,000 years ago. And this black dashed line on the inside of that is sort of this inner concentric ring fracture zone, which is also associated with the collapse of the caldera. And a lot of things have happened since the last super eruption and the formation of this Yellowstone caldera. There have been dozens of volcanic eruptions since then that have mostly filled in the caldera with more lava flows and lava domes, such that the caldera is no longer a big hole in the ground. It's almost all filled in. And another thing that's happened is that as the magma below has recharged and refilled this reservoir of magma, there are a couple of places where the ground is bulging back up, and these are called resurgent domes. And there's a place called the Mallard Lake Dome, and over here the Sour Creek Dome. And these are places where the magma at depth 5 to 10 kilometers down is pushing the ground back up. Now, the reason I show these geologic features is because they're really important in understanding where all the thermal areas are. And that's what I'm showing on this map in shades of red. That's where all the thermal areas are. So many of you probably know that Yellowstone is probably most famous for all of its thermal features. It has thousands of thermal features that are spread out over the park. There are hot springs and geysers and fumaroles, or hot gas vents, and mud pots. And there are just thousands of them all over the park. But they tend to be clustered together into zones we call thermal areas. So a thermal area is an area with a bunch of thermal features, and it also has hydrothermal mineral deposits on the ground and hydrothermal alteration of the rocks and the soils beneath. They also tend to be hot, radiating a lot of heat, giving off a lot of magmatic gases like water vapor and carbon dioxide and hydrogen sulfide. And they also tend to be pretty barren of vegetation. Vegetation is not happy growing in these places. It's too hot, and the soil is too acidic in a lot of cases. And so they tend to be pretty devoid of vegetation. And so that's what it's on this map in red. Now, the Yellowstone Center for Resources is one of the research groups inside the National Park Service. They're located at park headquarters. And they maintain a database map of all of the thermal features and all the thermal areas in Yellowstone. And this map is, it's a work in progress, partly because it's such a big area. There are a lot of places that we haven't really explored and characterized in great detail yet. There are still things to be found that we haven't found yet. And the other reason this map is a work in progress is because change is the rule in Yellowstone. Things are always changing. This hydrothermal system is very dynamic. And I'm going to show you an example of that in just a few minutes. So one of the things that I do for the Yellowstone Volcano Observatory in collaboration with the National Park Service is I sit in my office and I look at my computer screen and I look at satellite thermal infrared images of Yellowstone National Park. And I try to use this information to map out where all the hot zones are and I use this information to help assess and update where all the thermal areas and the thermal features are in the park. So a couple of years ago, I was sitting in my office looking at this Landsat 8 thermal infrared image that was acquired during the nighttime on April 20th, 2017. And on this particular occasion, I was looking very closely at this area right here, which is on the northeast side of the Sour Creek Dome. It's an area where there are a few thermal areas that have been mapped, and there are a few little lakes there. And I noticed something odd. I noticed this patch of bright pixels. Now, in a thermal infrared image, bright pixels are areas that are warmer, and dark pixels are areas that are colder. So on this map, you can see I have a few lakes identified here, and I have a few thermal areas that are shown in red, okay? And this is the Tern Lake thermal area, and this is the Fern Lake thermal area, named after the nearby lakes. Now, in the winter time in Yellowstone and in the early spring, almost all of the lakes in Yellowstone are frozen solid, and they stay frozen pretty much through May. But if there are any lakes that receive warm waters from nearby hot springs or underwater vents, they will either not completely freeze in the winter, or they will start to thaw out earlier than the other lakes do in the spring. So you can see here, White Lake is still completely frozen, but this western extension of Tern Lake right here is starting to thaw out, just as there are some warm areas inside Fern Lake that are starting to thaw out as well. So I'm looking at this and I see that the thermal areas, the previously mapped thermal areas, match up with warm spots, except for this spot right here. And so my first thought was, well, maybe it's a lake that just hasn't been mapped in. And so to answer that question, I turned to some high-resolution airborne images, color air photo images that were acquired in the same year, 2017. And you can see from this image on the right that this is not a lake, this is a patch of ground, barren of vegetation. It's got a bunch of dead, recently fallen trees, bright white soil. It looks just like another thermal area in the region. And so I thought, great, this is a thermal area that we haven't mapped yet. I'm going to go ahead and add it to the database. Everyone will be so happy. And then I thought, I wonder why no one mapped it before. Surely I couldn't have been the first person to see this. I wonder if it hasn't always been there. So I decided to investigate. I wonder how long it's been there. So I started looking at previous years' images, previous images of this thermal area, to see if I could figure out when it started. And so here's an image from 2017, which is pretty much what it looks like now. And I found an image from 2015 of the same area. Again, here's the previously mapped Tern Lake thermal area in red, and this is the new area that we're looking at. And in 2015, it looked pretty much the same. If we go back in time to 2012, it's a little bit different, maybe a little bit smaller, not quite as bright white soil there. If we go back to 2009, it's definitely different. It's definitely smaller, and you can see more trees in the area that are not fallen down, but they're starting to brown and become stressed. And if we go back to 2006, there's a big difference. There's just a little area of barren of vegetation here, and also up here, there's a patch of no vegetation, and then just browning trees around it. If we go back to 2003, it's even smaller. Again, you can see that patch of barren ground there and there with just a few brown trees there. There's an image from 2002, which is kind of difficult to interpret because it's a color infrared photograph. This before digital photographs were used, and you could see the patch of barren ground there and there. And the earliest image I could find was a black and white air photo from 1994, which shows that this was just forest back in 1994. So sometime between 1994 and 2002, something happened here that started killing the trees, and heat started coming up, and this thermal area grew. So in order to figure out when, I had to dig deeper into some more satellite remote sensing images to see if I could figure out when this started to appear. And so I found some, in some of the satellite data archives, I found some images from the late 90s. The image on the left is an image from a French commercial satellite sensor called SPOT, which was acquired in 1998. And the image on the right is a Landsat 7 image from 1999. And these images are colored using a false color composite, which is designed to enhance vegetation. Now, to the human eye, vegetation is green because it reflects mostly green light and absorbs more red and blue light. Now, vegetation is very reflective in the near infrared, just beyond what our eye can see in the red part of the spectrum. Now, these satellite sensors have channels throughout the visible and the near infrared. And so what I've done here is I've used a channel that's in the near infrared to drive the green color of this composite image so that vegetation in these images is really bright green, really intensely green. Areas that are barren of vegetation and highly reflective are bright white, and areas where vegetation is starting to die or decay or become stressed and turn brown are sort of pinkish to brownish in color. Okay, so that hopefully explains why these images look the way they do. And here are a couple of more satellite images from the Aster satellite that were acquired in the year 2000 and the year 2001. And here, I believe, is the first hint of evidence that we can see where the trees are starting to become stressed in this area. This pinkish brownish spot right here is exactly where that first area of barren vegetation starts to appear in this area. You know, and this is arguable, but I believe this is the first hint of evidence we have that this thermal area is starting to appear and stress the trees on the ground. So what I did was I went out and I grabbed all the remote sensing data sets that I could find for which I could estimate the area of this new growing thermal area and plot that on a graph. And so that's what I've shown plotted here in these triangles in the bottom of this graph. It started around the year 2000. It grew very, very slowly. And then around the year 2005, it started to grow very rapidly until the year 2012. And then it sort of slowed down and didn't grow very much after that. It sort of stabilized after that. Okay? And that's the new thermal area. In the circles on this graph, I'm showing the area, the surface area over time of this previously mapped thermal area. And so this previously mapped area has been there for decades, and it pretty much was the same size until about the year 2009. After 2009, it also grew a little bit. There was an increased area in tree kills on the top side, the north side of this thermal area after 2009. So that's kind of interesting as well. Definitely some changes going on over here. And so the next question I wanted to answer was, what about the thermal output? How much heat is coming out of the ground here? And how has that changed with time? So I grabbed all the remote sensing data sets I could find that had thermal infrared images that I could use to derive the temperature and heat output of this area, and I plotted that heat output versus time. And again, the triangles on the bottom part of this plot show the new thermal area. It started to appear around 2000, but it wasn't really that hot. It didn't really start heating up until 2004, 2005. And then it definitely increased significantly in the amount of heat it was outputting until the year 2012. And then it started to stabilize, and it didn't really heat up much more past that. And so that's consistent with the observations I made in the size of the area as well. It went through this period of slow growth, and then from 2005 to 2012, a period of pretty rapid growth, and then since then it's sort of stabilized. It may have even cooled off a little bit since then. So that's kind of an interesting story, I think. And the next big question is, what could have caused this? What could have caused this to happen? Well, in Yellowstone, there are a lot of natural geophysical processes going on that potentially could affect the way the hydrothermal system works. In Yellowstone, there's a hydrothermal system underground that relies on geologic fractures in open spaces in order for the fluids to be moving around. And in some cases, these fluids can make it up to the surface and present at the surface as thermal areas. And so it's possible and even likely that earthquakes, which happen frequently in Yellowstone, and ground deforming, bulging and moving up and down in Yellowstone can create new fractures and new cracks underground. And there are many examples throughout the history of Yellowstone of earthquakes and ground deformation being associated with the dynamic thermal system at the surface. And so let's take a look at earthquakes. One thing that happens in Yellowstone a lot is earthquakes, okay? On average, Yellowstone has anywhere between about 1,000 to 3,000 earthquakes every year. So if you look at this map, this is a map showing all the earthquakes in Yellowstone from 1994 through 2019. There are more than 40,000 earthquakes. It's amazing. But most of these earthquakes are much too small to be felt, much too small to be doing any damage at the surface. These happen, almost constantly, and nobody knows about them because they're so small. But it is theoretically possible for an earthquake, if it were placed in just the right spot, even a small one, it could theoretically, the ground shaking could theoretically open up some fractures underground and create new conduits for the hydrothermal fluids to be moving through and possibly even make it up to the surface. So could it have been some anomalous earthquake activity that caused this thing to happen? Let's take a look at the data. What I'm showing on the plot in the upper right is the number of annual earthquakes each year. And as you can see in the black bars, there are anywhere between about 1,000 and a few years. There are 3 years, actually, where there's a spike of more than 3,000 earthquakes in a given year. That happened in 1999, 2010, and in 2017. But none of those park-wide spikes in earthquakes really line up in time with the onset of this new thermal area or the evolution of it, the change in phase from slow to rapid to slow again. And the other point is most of these earthquakes were located on the western side of the park in swarms associated with tectonic faults, and they were much too far away from our area of interest to have really affected this area. Now, if we zoom in and take a look at just the earthquakes that have happened in this region, that's what I'm showing on this map in the lower right. Now, the interesting thing about this area is it's relatively quiet in terms of earthquakes. From 1997 into 2001, there were no earthquakes in this area at all within 5 kilometers of this thermal area. But 2009 was a very interesting year. In the early 2000s, there were a few earthquakes, but in 2009, there was a little mini swarm of more than 35 earthquakes that all occurred within a 2-day period in January 2009. But January 2009 happens right in the middle of that phase where the thermal area was growing really, really rapidly. So it couldn't have caused that phase to start. And that period of rapid growth continued for another couple of years after that spike in earthquakes. So it's very difficult to justify saying that the earthquakes had anything to do with this new thermal area. So what about ground deformation? Let's take a look at some data that we have for ground deformation. In Yellowstone, the surface of Yellowstone is moving up and down. It's going through cycles of ground deformation all the time. It's going up, it's going down very slowly, and we're talking about millimeters to centimeters of motion here over the course of months to years. And we monitor ground deformation in Yellowstone with a series of about 15 permanent GPS stations that are placed in key locations throughout the park. And they're constantly there, they're permanently there, measuring millimeter scale movements, north, south, east, west, and up and down movements of the ground surface. And the GPS station that's closest to our area of interest is a place called the White Lake Station. It's located less than 3 kilometers away from this newly emerging thermal area. And this plot on the right shows the elevation data associated with this monument. And what we see here is these data go back to the year 2001. We don't have any data from before that, unfortunately. But there are other methods that we use to assess ground changes in Yellowstone. There are techniques for using satellite radar data to measure ground elevation changes, and there are also field leveling survey data that we can use to assess how the ground was changing in the years before this. And it turns out that from the mid-90s until about 2005, this whole area was going down. Slowly but surely, it was subsiding a little bit. And then in January 2005, it started going up. And it started going up pretty rapidly. It rose about 20 centimeters over the period of about 4 years until 2009. It peaked, and then it started sinking back down again. And then from 2014 to 2015, there was a little uptick, and then it's been subsiding ever since. So that's interesting. 2009. That swarm of local earthquakes in 2009 fits right underneath that peak in ground deformation. And that makes sense. There's a lot of evidence in Yellowstone that ground deformation and earthquake swarms are coupled and causally related like that. And it really does stand out. It's really tempting to look at this graph and say, look, here we have at the very beginning of our rapid growth phase coincides almost perfectly with the beginning of this rapid rise in the ground. And it certainly is logical to imagine as the ground rises, you're creating space. You're cracking brittle rocks and creating more open spaces for hydrothermal fluids to move around. So it certainly is possible. If you look very closely, there's a little bit of a time lag between the beginning of this and then the beginning of the rapid growth phase. But that's one of the most interesting things about it, is that it's not really clear cut. And this may not be very satisfying to you all, but it's satisfying to me because it means there are still questions we have yet to answer about this. The growth of this new thermal area does appear to be associated with this ground deformation, but it's not totally clear cut. And that's where we are right now with this. We don't have any information about gas emissions, the history of gas emissions from this area. And so maybe in the future we'll do some more research to figure that out. But in our efforts to understand what's going on here, we are also trying to understand hazards in the park. And one thing is clear, and there's no question about it, this is a new thermal area that's appeared in the last 20 years, and it's definitely a hazardous area. You don't want any backcountry hikers to be meandering around this area, because this is an area of very hot ground, unstable ground. It's possible to be walking along and have your foot break through a crust and end up immersed in sort of steam, boiling temperature steam, and you wouldn't want that. And there are also noxious gases coming out of the ground here, a lot of hydrogen sulfide and carbon dioxide gas coming out of here. And as you can see, it's not very friendly to the vegetation. We did get a chance to go out and explore this area last summer, August 2019. And we flew out there in a helicopter and were able to acquire some images from helicopter and also some thermal infrared camera images, which revealed this arc-shaped zone of very, very warm ground where the surface temperature is between 60 and 80 degrees Celsius. And just beneath the surface is boiling, 93 degrees Celsius. And there were some steaming fumaroles that you could see in the area. And we were able to sort of carefully skirt around the edges of it and map out the boundary of this area and get a good idea of how big it is. It's about 8.2 acres in size. And to put that in perspective, that's about the size of 4 soccer fields sort of stuck together. There's no water coming from this area. It's a dry, what we call acid sulfate, steam heated acid sulfate thermal area, where the soil is sort of acidic and there's a lot of sulfur crystals forming underneath the fumaroles. One of the interesting things that we observed was these dead trees that had fallen down and were in contact with the warm ground were starting to carbonize on the bottom of the tree. They're basically slowly combusting where they were in contact with this really, really hot ground. And in places where these trees were next to a gas vent, there were sulfur crystals coating the carbon on the wood, which was pretty amazing to see. And another really interesting observation we made is that there's this cool zone that's in the middle of this, where there are new trees starting to grow. So there are new, less than 5-year-old lodgepole pine trees that have started to come back into this area. And so maybe it is in the process of cooling down. We will see. But the bottom line here is that, this is what Yellowstone does. Yellowstone is a very dynamic thermal area. What we see at the surface is the expression of this hydrothermal system of fluids moving around underground, which is heated up by magma at depth. And this this is not an indication of magma moving around. This is an indication of hydrothermal fluids moving around. So if anybody's concerned about this being a signal of an impending eruption, it's not. It's just Yellowstone doing what Yellowstone does. And that's pretty exciting. So what we will do is we will continue to monitor this and look for other areas in the park that may be developing or decaying, and we'll just keep track of how Yellowstone's dynamic hydrothermal system changes over time. Thank you for listening, and I hope you all are as excited as I am about the new discoveries we're making, and stay tuned for more.
Wow, Greg, that was just wonderful. Besides the science, I just really appreciate your excitement. And I think it's fitting. Our first question I want to ask you is actually coming in from a 9-year-old. His name's Vinny. He's here in Flagstaff, and he's wondering how hot geysers are.
Okay, great. Can you hear me okay?
Yeah.
Okay, great, thanks. Thanks for your question, Vinny. That's a good question. Geysers are boiling water. And so in Yellowstone, the elevation is so high, it's a little bit higher than here in Flagstaff, that the temperature of boiling water is about 93 degrees Celsius, which is about 200 degrees Fahrenheit. That's the temperature at which water boils up at that type of elevation. And so the middle of hot springs where the water is coming out and geysers right at the surface are boiling 93 degrees Celsius.
Wonderful. We have another question. It seems like the new thermal area and the ground uplift are related, but what's making you skeptical of that?
Yeah, that's a good question. The reason I'm sort of cautious about that is because it's just not so clear. As I said in my pre-recorded talk, there is a correlation in time between the onset of this of rapid bulging of the ground and the rapid growth of this thermal area, but there's a time lag which you could explain. But for me, the biggest, let me put it this way: if you claim that it was the ground bulging that caused an increase in the circulation of hydrothermal fluids and brought hydrothermal fluids to the surface and caused this new thermal area to appear, you have to explain why that doesn't happen all the time elsewhere in Yellowstone. This sort of thing happens occasionally, but when the appearance of a new thermal area like this, a really big area of tree kills, that doesn't happen that often. Maybe once every 10 years or so, you see something like this happening. Yet ground deformation cycles are going on all the time. The ground is moving up and down and up and down. And so if you're going to create a new pathway for hot fluids to come to the surface every time the ground bulges, why does this happen frequently elsewhere? And so that's one of the things about it that's still complicated, and that's one of the reasons the relationship between those two things is still, we don't fully understand it, I don't think.
Wonderful. Thank you. Just a reminder for everyone, the questions are coming in live right off our website, scifest.org, right there in the homepage. Quick submittal on questions. And so we have one from Becky here in Flagstaff. She notes Flagstaff is very volcanic. Is there a chance of something like this happening in the Flagstaff area?
Well, over geologic time, just about anything can happen, right? Not anytime soon, though. So right now, yes, Flagstaff is in the midst of what we call the San Francisco volcanic field, which is a field of about 600 or so volcanoes that have erupted here in the last 6 million years. The most recent of which is Sunset Crater, which is less than 1,000 years old. But the climate's very different here in Flagstaff. It's very high and dry. And the climate in Yellowstone is much wetter. And so one thing that Yellowstone has in their high altitude volcanic plateau is they have a lot of water. There's a very large hydrothermal system sort of in between the magma and the surface. And the heat from the magma at depth is driving circulation of that hydrothermal system, and occasionally it makes it up to the surface. We don't really have anything like that happening here right now. And I don't even know how much magma there might be down beneath the San Francisco volcanic field at this point. There's probably some, but I actually don't know. We don't know how much. It seems, if you look at the history, it seems likely that there may be eruptions here again someday, just as there may be eruptions in the Yellowstone area again someday. But for right now, there are no hot springs or geysers or fumaroles or mud pots anywhere in northern Arizona. So we're a long way away from having this place look anything like Yellowstone.
Kind of related, here's a great question from Karen in Flagstaff. She's wondering, are there similar areas like Yellowstone in other parts of the world?
Yeah, there are. There are geysers. Well, yeah, there are hot springs and geysers and gas vents. Anywhere you have volcanic activity, active volcanoes, you have places where there are geysers and hot springs. But there are a lot of places in the world that are sort of famous for having a really large field of geysers and hot springs. There are some in Iceland. In fact, the word geyser is originally an Icelandic name, I think. Sort of the type of locality of geyser is located in Iceland. There are other geysers in eastern Russia on the Kamchatka Peninsula. There's some down in South America in the Andes. There are a number of other places in the world where you have this type of activity. Yellowstone just it's the biggest. It's the largest concentration of hot springs and geysers.
Wow. Wonderful. Well, Mark from Colorado Springs is wondering, how common is it for a new thermal area like this one to form?
Yeah, that's a good one. I think maybe on the order of once every 10 years or so, we see something like this happening. In my sort of review of the literature in writing a paper about this, back in the late 70s, there was some increased thermal activity in Norris Geyser Basin, which caused some trees to die and increased the size of the area. That happened again in 2003 in the Norris Geyser Basin. There's another area called the Mud Volcano thermal area, which is on the sort of the southwest side of the northeast side of the Sour Creek Dome, which is in the northeast part of the park. That happened in the late 70s, 78. There was an increased area of tree kills there. Just in 2018, there was some increased thermal activity in the upper geyser basin across sort of the hill from Old Faithful. So these things happen every now and then, but I would guess maybe once every 10 years ago, we see something where you have a really significant change in the surface, like a big new area of dead trees and new mineral deposits.
All right. Ken in Flagstaff is wondering, when was the last significant volcanic eruption in Yellowstone?
Okay, 70,000 years ago. I mean, I would say any volcanic eruption is a significant eruption. But the last really, really big super volcanic eruption was 631,000 years ago. And then there were, there's several dozen eruptions after that, lava dome and lava flow eruptions that have occurred since then. And the most recent one, the last time any magma came out of the ground at Yellowstone was about 70,000 years ago.
Okay. Well, and I'm thinking we've got these questions coming in, and I'm thinking folks who aren't even asking them are thinking this. So I'm going to kind of lump them all together. Do we think it will erupt again? Is it building up to erupt again? Are we due for another eruption? And I'd probably like to add in there, and if so, will we know? What's the science behind keeping an eye on this?
Yeah, there's a lot of hype about Yellowstone, and you hear a lot about it because of its sort of famous history. So where do I begin? I mean, it's an active, it's a dormant volcanic system that has a lot of activity, and given its history, it seems likely that there will be something will continue to happen. We know that there's still magma, a reservoir of magma at depth. It's anywhere between 5 and 10 kilometers down, and then sort of beneath that, it's being fed by a mantle, what they call a hot spot, a plume of hot material rising up from deep in the mantle. So that's keeping this place hot. It would have cooled off a long time ago if it weren't continuously supplied with heat and mass from the mantle. It would have cooled off a long time ago. So it's still hot, obviously. We can see that at the surface. And so will it ever erupt again? Probably. But you can't predict far in advance when a volcano is going to erupt. They just sort of, they operate on their own schedules, and they don't, not on a regular schedule. So I would say probably, but we don't know when. But one of the important things to note is that most of the volcanic eruptions in Yellowstone are not really big explosive super eruptions. They're mostly lava flow and lava dome eruptions that are really not even necessarily that explosive. So statistically speaking, another eruption in Yellowstone that may happen in 10,000 years from now or 1,000 years from now is more likely to be a lava flow or lava dome type eruption. So the worst case scenario is the least likely scenario, right? And the other, you asked a lot of questions there, and I'm trying to remember them all. The other comment you made was about whether or not it's due. A lot of times you hear people talk about whether or not it's due for another eruption, because there have been 3 really, really big eruptions there, what they call super eruptions, in the last 2.1 million years. And if you look at the recurrence interval between them and try to calculate an average recurrence interval, it wouldn't really be due for another 70 or 80 or 90,000 years. But the problem with that is statistically, it doesn't even really make any sense to try to calculate a recurrence interval from just 2 data points. And because volcanoes just don't operate on a regular schedule like that. So don't worry about if anybody ever hears you, if you ever hear anybody say it's due, you can just say, okay, let's do the math, and you can figure out that that's not the case. It's not something to worry about. But it maybe we'll erupt again someday, but we don't know when. Did that cover all the questions you asked there?
It did. Just to maybe the one final one I slid in there to clarify, are we monitoring it from a
Yes. Yeah. How would we know? Right. That's a really important question. Yeah. Yeah. Volcanoes, even though we can't predict them, they do give us warning signs. There are earthquakes, and the ground deforms and bulges, and they give off a lot of heat. They give off a lot of magmatic gases, and they do this in very anomalous ways before eruptions. Now, really small eruptions are very hard to predict. Really small eruptions can happen with very little to no warning. And the bigger the eruption you expect to have, really the more intense and the longer duration the warning signs are. And that's one of the reasons we do monitor Yellowstone is we want to know what Yellowstone behaves like normally, so that we know how to recognize anomalous activity if it ever happens. Yellowstone is already anomalous in that it has earthquakes and ground deformation and hot and heat and gases coming out of the ground. It behaves just like an active volcano should behave, except it's not erupting, right? But that's what the background status is for Yellowstone. That's one of the things that's so interesting about it. Its sort of background levels of activity are that. And because we are monitoring it carefully, just like we monitor any other volcano in the world, we will know, weeks to months to years ahead of time before anything really anomalous starts to happen.
Wonderful. Well, good. There's some comforting information in there. And we continue to have a lot of questions coming in. We've inspired a lot of curiosity. So thank you, Greg. This is wonderful. Pat from Williams is wondering if there's volcanoes under Arctic or Antarctic ice.
In Antarctica, yes. I don't know so much about the Arctic, because that's just an ocean up there. But on Antarctica, there are volcanoes. There's an active volcano in Antarctica on Ross Island called Mount Erebus. It's one of the hottest. There's a lava lake there. There's literally a lake of lava. One of the hottest places you could be on Earth in Antarctica, one of the coldest places on Earth. Pretty cool.
Wow, fascinating. Yeah. All right, so Andrew's wondering, has your research helped other scientists use similar studies to look at different areas in the park to see if there's an increase in growth of thermal area?
I hope so. All the scientists who study volcanoes in Yellowstone and elsewhere, we all sort of collaborate and work together. And so, we get ideas from each other and inspire each other. So I hope so. Yeah. I mean, do you mean specifically in Yellowstone or elsewhere in the world?
I think it looks specifically in Yellowstone,
Okay.
but I think the audience would be interested for
Yeah,
either.
well, yeah, I mean, there are other ways to look for thermal areas as well. And something that I'm becoming increasingly interested in is searching for signs of stressed vegetation. When the ground starts to heat up, um, and underneath healthy forest, the vegetation becomes stressed and trees start to turn brown instead of their evergreen color. And that's one of the earliest signs I think we start to see when a new thermal area starts to appear. And so, this research and the research of others who study vegetation stress and it sort of is coming together, and it's an area of research that I hope to pursue in the future, looking for other areas in Yellowstone and elsewhere, um, to help identify places where new thermal areas are coming out.
Great. Alex in Flagstaff is wondering, we can see the trees are affected. What about wildlife, and is it safe for humans to be close to this area?
Um, I think that wildlife is probably smarter than we are when it comes to avoiding dangerous areas in Yellowstone. That's their home. They live there. They know more about it than we do in some ways. Although there are examples of wildlife like bison in Yellowstone, which occasionally are observed with burn scars on their legs. Even the bison sometimes step where they shouldn't, and their foot breaks through a crust into boiling, super hot area, and they get third-degree burns. That happens to people, unfortunately, as well. That's one of the reasons the Park Service is so adamant about staying on trails when you're in the park, to observe the thermal areas from a safe distance away. If you do step off the trails, the ground can be very unstable in these thermal areas. That's one of the hazards. You can be walking along and your foot can break through what looks like solid ground, but it's actually just a shell. And your foot can break through and either become immersed in boiling water or steaming, boiling fumarole. And that would not be good. There are noxious gases coming out of the ground there, carbon dioxide and the nasty, stinky, rotten egg smelling hydrogen sulfide. And some people are very sensitive to those. But even if you're not, a really high concentration of those gases that aren't oxygen, which is what we need, can be hazardous to your health as well. And those are just some of the main hazards associated with these thermal areas.
All right.
Yeah.
Mark in Flagstaff is wondering when the last time before this was a new geothermal area created in Yellowstone.
I think the last time there was a sort of a healthy forested area that suddenly killed a bunch of trees, it happened back in 2003. In March of 2003, just north of where Norris Geyser Basin is, there was a what they call a thermal disturbance in the area. And just north of Norris Geyser Basin, there was a line of trees about almost as long as a soccer field and maybe just 5 or 10 meters wide, where there was a line of new fumaroles that opened up and started spewing out hot gases and minerals, and all those trees are now dead. And so I think that's the last time anything like this really closely related to this happened, 2003.
All right. Well, and I'm thinking here we might have a really fun question to close out on. Watching you present and seeing your excitement over your research, it really gets me thinking. I can almost picture you as fifth grade Greg and first grade Greg, having this curiosity and having this creativity. And I think that's one of the magical things about the festival is bringing that permission for creativity, that permission for curiosity, especially to young people who might not otherwise have access to science, but to all young people, to their parents, their caregivers, to really just give that permission and that excitement. And so I think our closeout question here is from Raphael, wondering, where do you recommend a visitor check out in Yellowstone other than famous landmarks? What are the things to see there?
Oh, so if you're going to go to Yellowstone, well, okay, first of all, my answer is going to be biased because I'm a geologist and I study hot springs and geysers. I think the greatest things to see in Yellowstone are all the thermal areas, and there are some really amazing thermal areas there. they're very different. Like if you, the north side of the park near Mammoth Hot Springs, well, Mammoth Hot Springs itself is a travertine hot spring. It's made of material that's completely different from other hot springs in the park, and it looks different, and it's really amazing. So Mammoth Hot Springs is one place. If you've never been there before, you sort of have to see Old Faithful just because it's so famous. And you know where the roads are in Yellowstone pretty much takes you to all the highlights. There are some geysers that erupt in Yellowstone that are even bigger than Old Faithful, and if you happen to get lucky and catch those, that's a real treat. Grand Geyser and Great Fountain Geyser, and of course, in the last couple of years, Steamboat Geyser in Norris Geyser Basin has been erupting about once every week. It's not predictable, but it's on average every once a week or so. Steamboat's been erupting, and that Steamboat Geyser is the tallest active geyser in the world. It shoots water out a football field high, 300 feet high. It's incredible. And I have not seen Steamboat erupt yet, but I hope to someday soon. Let's see. Other than geysers and hot springs, I mean, the scenery is just spectacular. If you just drive around Yellowstone Lake and stop at the stops and look at the scenery of the land, that's pretty spectacular. And of course, if you can see some of the really cool animals in Yellowstone, Yellowstone's also famous for, you know, very, as they say, charismatic megafauna, the really big bison and elk. And if you're lucky, you can see a bear or a family of bears, grizzly bears and black bears. If you're really lucky, you can see wolves or mountain lions. I've not seen wolves in Yellowstone before, but the animals there are spectacular, and the birds and the scenery.
Yeah, I couldn't agree more. If you have not visited Yellowstone, you must go. It's so much to see, so much to describe. So for everyone, we want to thank you for tuning in and really celebrate our 31st year at the Flagstaff Festival of Science. We really want to encourage you to be creative, to be curious, to explore. And this year, because we're all recorded and online, you can go back, you can see the ones you've missed, you can share with your friends, you can use with your children in the evenings. We've got lots of material on the website, scifest.org, and make sure you help support us through donations and especially by doing the surveys for each event you took. We can't specify enough how important that is. Again, from all of us at the festival, thank you so much for tuning in this year, and we're all hoping to see you next year. Bye.
Thanks. Bye.